Hey guys, it's Mr. Win, and we're going to talk about system of inequalities. So what do I do if I don't have an equal sign, right? We're used to solving when there's an equal system and you get 1 point, that's your solution. But here, all right, we're going to ask ourselves, how do I solve system of inequalities? All right, that's going to be your essential question. So make sure we write that at the top. All right, so I'm going to talk about these graphs, all right? Normally you have two graphs, two lines, they cross at a certain point, that's your solution, right? In this case, you're going to have two regions, all right, two shaded regions, and wherever those overlap, your solution set will be within those, those overlapping regions. So now I could graph these two equations. 2x minus y is greater than or equal to 2, and 2x plus 3y is less than 6, all right? And then find out the overlapping region. Now, I know you can go to the calculator to graph this. I'll show you how to do that in a second. But if I just did this by hand, all right, you can find your intercepts because these are in standard form. So again, if I want to find where it crosses the x, imagine the y is gone, right? And solve. That means the x is going to be at 1. I do the same thing for the y. Imagine the x is gone. So where would it cross the y? Well, I got to divide by -1. That means the y would cross at -2. All right, just a reminder, did that pretty quickly to show you how you can graph this by hand. All right, but also pay attention. Remember your rules of inequalities, all right? There's a line underneath their symbol there. That means I am actually going to draw this solid line here, okay? And I know this is kind of a rough sketch. I'm not drawing very exact, okay? But you have the general idea. There's our line. If I graph the second equation, again, get your intercepts. Where would it cross the x at? Imagine the y is gone. It would cross it at 3. And where would it cross the y at? So imagine the x is gone. And solve. That means it would be at 2. All right, and then you want to look at your symbol. So again, focus on the symbol. This is less than, right? No line underneath. This is not less than or equal to, just less than. That means that line is not really there, okay? So, but we do have to draw this boundary. So we got to draw our dashed line, right? That boundary. So the region does stop there, but does not equal to that line, okay? All right, and don't forget to do your shaded areas. So if I were to shade the first equation is greater than, so you want to shade above the point, right? So greater than, which would be to the right. Right here. All right, and then you also want to shade less than. So on the green area, you're going to shade less. I'm going to shade this in pink. All right, so less than that line over here to the left. Okay, and of course, you can go to the calculator, graph this in there, but now we know the region that is both shaded. It's that darker blue, correct? All right, now let's figure out which of these are actually solutions. Well, if I check -3 and 1, that means I'm going to go back to -3 down to 1. This is the point here. Let me use the color here. Yeah. -3 and 1 down here. That is only in the pink shaded area, right? So that is not a solution. Okay. What about 2 and -2? Well, let's go over here. 2 and -2. So 2 down to -2. Yes, that is a solution, right? That would work. And then it says 1 and 5. Let's check 1 and 5. So that's that 2. Okay, 1 and then go up to 5. 1, 2, 3, 4, 5 right here. That is in neither shaded area, not a solution. How about 3 and 0? 1, 2, 3, 0. So the point is right on that dotted line. So that point I just drew in black, right? That point. It's right on the line. But remember, it's a dashed line, right? So it does not reach that. So that means that is actually not a solution. Now, if you happen to have a line that were on, like, say, the solid line, yes, that's a solution, but the point we just drew is a dashed line. It is not on there. That line is technically not there. It goes all the way up to that point, but that is not a solution. So make sure we know that 3, 0 is actually not a solution. What about 1 and -4? If I go to 1 down to -4 here, right? Yes, in our region, it is a solution. So the only solutions are 2 and -2 and 1 and -4. All right. What if I have a situation that says the World Travel Club has been awarded a grant and is allowed to take students on a trip to either London or Paris over the summer? It costs $2,000 to go to London. That sounds important. And it costs $5,000 to go to Paris. Okay. The cost must be less than or equal to, all right, we know this is an inequality, $4,000. The World Travel Club can only send a maximum, so again, at least, all right, at most, 14 students. Write a system of inequalities to model the situation. Well, $2,000 to go to London. Let's just say L for London. And actually, let's use this as our variables of X is going to be London, Paris is going to be Y, okay, just so we can put in the calculator to graph this. 2,000X plus your trip to Paris, so $5,000 for every student that's going to Paris. So however many that is, Y, whatever it is, you will multiply it by 5,000, so 5,000 Y. The cost must be less than or equal to, that's our less than or equal to, less than or equal to $40,000, all right? And then it says the World Travel Club can only send a maximum of 14 students. Well, there's two types of students. There's the students that want to go to London, and there's the students that want to go to Paris. But they can only send 14, so when you add those up, they must not, okay, be greater than with a maximum of 14. 14 has to be bigger, less than or equal to 14, all right? The club has 6 students who want to go to London and 8 students who want to go to Paris. So that means, is 6, 8 going to be a solution? Well, let's go to our calculator and graph this and see, is 6, 8 going to be a solution? Well, I have a calculator here. All right, it's your Inspire. Remember, we just go to graph. And to graph these inequalities, we're going to go to, let me clear that. We're going to go to delete the equal sign, and we're going to go to relation, right? Remember, you got to go to relation. And then graph your equations. Remember, I had, if you needed to check, 2,000 x plus 5,000 y is less than or equal to 40,000, right? That's the max you can spend. There's one equation. And then press tab again to put the second equation. It was x plus y less than or equal to 14 students. All right. Will 6, 8 show up? I mean, it's a little hard to see right now, but if I go to menu and I want to view the grid lines, view grid, line grid, I can easily count this, okay? So remember, what were we checking? 6, 8, right? So if I count over to 6, excuse the bell. All right, so if I count over to 6, let me just draw on this. I know you can't, but 1, 2, 3, 4, 5, 6, and then up to 8. 1, 2, 3, 4, 5, 6, 7. Well, out of our region, not a solution, okay? So if I go back to this, all right, no, all right, not a solution. All right, and that's it. Thank you.